Okay, today in this video, we are going to do a problem about calculating the pH or pOH of a solution given the concentration of certain ions. Now let me read the problem. Calculate the pOH of the solution of hydronium ion concentration of 9.47 times 10 to the negative 8 molar. Now, if you know anything about pH and pOH, you know that they are opposites. pH and pOH are opposites. And pH uses the hydronium ion concentration, but pOH uses the hydroxide. But they give us hydronium, and they ask for pOH. So if you're like going through the problem really quickly, you're not going to see this, and you're going to use the wrong formula, and you get the wrong answer. So you have to read the problem slowly. Now, you know pOH takes hydroxide, pH takes hydronium, so how are you going to solve this problem? Since they gave you two things that are opposites. Now actually, what you got to do is you got to think about the scales of pH and pOH. The pH scale is from 0 to 14. Less than 7 is more acidic, more than 7 is more basic. And pOH is the exact opposite. Less than 7 is basic for that. And greater than 7, less than 14 is acidic. So the way it works out, because these two are opposite, because hydronium is plus 1 and hydroxide is minus 1, the pOH of anything plus the pH of anything of that same anything is going to be 14. Because let's say you have a substance which has a pOH or basic, it's basic, you're gonna get like a third, in the pH scale, which people are more familiar with. You have substance that is basic. Let's say it's 13. That's its pH. Its pOH, it's going to be basic, and remember, for pOH, basic is less than 7. It's going to be 1. So those add up to 14, because pH and pOH are opposites. So, in the problem, they want you to find pOH, but they give you the hydronium ion concentration. So how can you do this? Now, there are many ways. This is not the only way I'm going to do, but the way I find easiest is to just subtract pH from both sides, and you get pOH, which is, remember, is what we want to solve for, is equal to 14 minus the pH. So now all we gotta do is find the pH, take that and subtract it from 14. So remember, the pH formula is negative log hydronium concentration, H plus. Now what you gotta do is you gotta substitute this in for that, and you will on your calculator, and you will get the answer of 7.024. 7.024. Now, what does this tell us? The pH is greater than 7, so that means that this is a basic solution. This is basic, which means that if you find the pOH, it will be less than 7. So if this is a multiple choice test, and you found that the pH is greater than 7, and you ask for pOH is going to be less than 7, you can automatically eliminate all those answers, which are like 8 and 12, all the ones greater than this. So now you take this and subtract it from 14, so 14 minus 7.024. You can do this in your head or plug this in on your calculator, and you will get 6.974. 76, yeah. Now this means that it's basic, because this is the pOH equals pOH. So this is your answer right here. Now, it gives us 3 significant figures, so we have to put this to 3 significant figures. And for 3 significant figures, you would get the answer of pOH equals 6.98. That is your answer. Now, you guys just solved the problem and you guys just got an answer. But what does this mean to the problem? Like, sometimes I like thinking about, what does this mean to the problem? So, what it means is that the solution you're dealing with is basic, because this is less than 7. Now, how you can think of this is that we all know that the neutral for a neutral compound, the amount of hydroxide ions and hydronium ions is going to be, the molar of that is going to be 10 times 10 raised to, 1 times 10 raised to the negative 7. So it's going to be 1 times 10 raised to the negative 7. 1 times 10 raised to the negative 7. And if you write this out, you're going to get 0.0000006 zeros. And then a 1. 0, 0, 0, 0, 0, 0, 1. And in the problem, it gives you 9.47 times 10 to the negative 8. So that's 9.47 times 10 raised to the negative 8. And you'll get here 0. If you like expand this out, 0, 0, 0, 0, 0, 0, another 0, and then 9, 4, 7. You see these numbers? These numbers are really close. These numbers are really close. 9.947. Like this actually was very close to rounding up to a 1 right here, but it doesn't quite round up. So, and it doesn't give us. It gives us a really close and exact amount. So that means that this solution is pretty close to neutral and not extremely basic. But it is still slightly basic, and you found your answer of pOH. Yeah.